All right, so we're going to talk now about special angles, and in the next video about cofunction identities. But we're going to start off with thinking about our three special angles, right? So if we consider just a regular square, right? There we go. There's a square. And we can, we don't know what the sides are, so we just call them x. And if we draw the diagonal, just like that, what kind of triangle do we have? Well, obviously, it's a right triangle, right? But we also know the angles here because we just bisected the right angle. So we do know that those are 45-degree triangles, and we also know that it's an isosceles triangle because the two sides are equal. Okay, so we'll say I'll probably misspell that completely. Whatever. You know what I'm talking about. Isosceles triangle, and the angles are two 45-degree angles, of course, and a 90-degree angle. All right, so that's what we've got right there. So the question is, what is the length of the diagonal D, right? So we've got x on one side, x on one side, x on both sides, all sides. We want to find the diagonal. And of course, we're going to do that with Pythagorean theorem, which I can spell mostly. So we're going to say, hey, I got one side x, so x squared plus the other side squared equals the diagonal squared, right? A squared plus b squared equals c squared. So we've got what? 2x squared equals d squared. D is equal to the square root of 2x squared, which is root 2 times x. Okay, so there's what our side is, right? So this is root 2 times x. Oops, that's the same picture there, right? So we can summarize that pattern that anytime we have an isosceles triangle, whatever the sides are, x, x, root 2x. So on a unit circle, right? Or, just to make our lives easy, we're going to say, hey, let's make x equal to 1. We've got sides of 1, 1, and root 2. Or if you're thinking about the unit circle, because in the unit circle, of course, let's draw our unit circle, 45-degree angle, right? So which side is 1? It's going to be the diagonal, right? So there, we've got 1 on this side. And what does that mean? That means that this has got to be 1 over root 2, and this side's got to be 1 over root 2, otherwise known as root 2 over 2. Okay? I prefer to not have to remember fractions, so I normally remember this pattern for my 45-degree angle or my isosceles triangle, so that I can get all of my trig functions just by sketching this triangle really quickly for 45 degrees. And then I have, of course, sine 1 over root 2, cosine 1 over root 2, tangent 1 over 1. There we go. Okay. So second special angles, right? Now we're going to consider an equilateral triangle, right? What does equilateral mean? All angles are the same. So all angles are equal, and therefore, since the angles have to add up to 180, that means our angles are all 60 degrees or pi over 3 radian, right? So we can draw an altitude, which just means drop a perpendicular. So we've got a right angle there, and we know that this is 60 degrees. And since this thing is symmetric, we also know this other angle, and the angle's been bisected by the altitude, so the angle is half. It is 30 degrees. All right, there's my thing. So 60, we really got 30, 60, 90, right? Those are our angles. So if we say, hey, we want to find the length of the altitude A, this is actually a pretty easy problem. We're just going to say, well, hey, I didn't say how long the sides of the triangle were, so let's say x. We know that this distance has to be x over 2 because our angle was bisected, and that means that we've cut the opposite side because it is equilateral. We've cut it in half. And so again, Pythagorean theorem, right? So we've got x over 2 squared plus our altitude squared equals x squared, right? So adjacent side squared plus opposite side squared equals hypotenuse squared. And we want to solve for a, right? So a squared equals x squared minus x squared over 4. And we can say, hey, that's 3/4 x squared. And then we can square root things, right? So root 3 over 2x. All right, so there is our altitude. Okay, so, oops, let's go back. So we're going to summarize this, right? We've got our hypotenuse, distance is x. We've got for our 60-degree angle, let's say. We've got this side, which will be x over 2, and from what we just figured out, the other side's going to be root 3 over 2 times whatever our triangle length is. And so again, we have 30 degrees here, right? So really what we have is a second triangle that we can draw. All my triangles tend to look the same. We'll do it a little bit better there, right? Actually, we've been looking at 60 degrees, so we'll do this. Right, so we've got the long side, we're going to make that 1, right? X, doesn't matter, right? It's x. This is going to be x over 2, and this is going to be root 3 over 2x. So if we say, hey, let's make our life easy, and let's let x just be 1, which also happens to correspond with the unit circle, right? Because that's our radius here. 1, 1/2, and root 3 over 2. And so now we know for 60 degrees we can find our sine, right? Root 3 over 2 over 1. Our cosine, 1/2 over 1. And our tangent, root 3 over 2 over half, otherwise known as root 3. We can do the same thing with our 30-degree angle, right? We don't have to draw a new triangle. We just have to remember to think of it in terms of opposite and adjacent sides, right? And when you set this up, whether you set it right to draw your triangle like that, or you draw your triangle like this, whichever side you want the small angle to be, whichever angle you want your small angle to be, the small side's going to be opposite the small angle, right? So my 1/2 is going to go across from the 30 degrees, 1's going to go on the hypotenuse, and root 3 over 2, which is about 0.866, is going to go on the longer leg. So there you go. So even if you forget how to label these triangles, if you remember that the 30, 60, 90 information comes from the equilateral triangle, all you've got to do is apply Pythagorean theorem. And if you remember that the 45-degree triangle comes from cutting a square in half, right? And using the Pythagorean theorem, that's all you're going to do. It comes up pretty quick. I'm not a big fan of memorizing and going through and drilling and drilling and drilling on the unit circle. You may prefer to do that. That is fine. But it's up to you. But on tests, I may very well ask you, hey, here's the 45, 45, 90 triangle. Here's the 30, 60, 90 triangle. Label the sides and angles, right? Might ask you to do that. All right, that's it for this video.